So we built our first basic widget app that leads to this user interface. And before we'll dive deeper into that and make it a bit more pretty and of course work towards our final application goal for this section, I want to dive into another crucial Dart feature, which is extremely important and which you must understand in order to work with Flutter and Dart. Because of course, this section is not about building the final app as quickly as possible, but about learning all these important Flutter and Dart fundamentals. And one important fundamental Dart concept that you must understand is the concept of types, because Dart is a so-called type-safe language, which in the end means that all values you're working with are of certain types. For example, this hello world text is a so-called string. If we had a number like 29 in our code, it would be of type int. Material app is of type material app. And actually, there's not just one type per value, but instead values are typically of multiple types. For example, this hello world text is not just of type string, but also of type object. The number is not just of type int, but also of type num and of type object. And material app, for example, would be of type material app, but also widget and also object. So values can be of multiple types. As you see, for example, all values are at least of type object, and then they also have more specific types. And I'll get back to objects and what's that all about a little bit later. And those types are either built into Dart or provided by a third-party package or provided by you when creating your own types, which you typically do implicitly. And in our application here, we're also working with types in a lot of different places. But why does this type feature even exist? Why does it matter that this text is technically of type string? Which you, by the way, can also see if you hover over it, because then the code editor shows you some information about the thing you hovered over, and that always also includes the type of that value. For example, here string. For a material app, it's a bit harder to see, but here the type annotation would be this thing in front of this material app function argument information. But why does this type feature exist? It exists and it's enforced by Dart to make sure that you're never accidentally using the wrong type in the wrong place. For example, you might want to display a number on the screen, and therefore you could replace hello world with that number. But you would see that here in my code editor, I'm now getting an error. When I hover over this, I learn that here in the end, I can't provide a value of type int, which is that number type, which you just saw a couple of seconds ago on the slide, to a parameter that actually wants a string, so that wants some text. Put in other terms, the text widget internally, as it was defined by the Flutter team, only knows how to work with string input values, with text input values. It does not know how to work with numbers. Of course, you could argue that displaying a number on the screen should be possible, and it is if you convert this to a string by wrapping it with quotes, which in the end is what those quotes really do. They create a so-called string, text. But of course, numbers are a special case. What if I would pass a material app widget here? Now it might make more sense that text can't output this, because how should this material app widget, which is all about creating the frame for an application user interface, how should that be output on the screen, right? How should that be treated as text? And to make sure that the text widget doesn't have to guess what it should do with its input values and how it should output those values as text, the Flutter team built the text widget simply such that it only accepts text, that it only accepts strings to be precise. And you can also see that if you hover over it to get more information about it, here you see that first argument, the only positional argument, positional parameter wanted by the text widget, which is that parameter we're setting with that first value we're passing between those parentheses. And here you see this annotation in front of data. Data is simply the parameter name, but the annotation in front of it is the type that's expected for this parameter. And if you would create a custom function, which you want to use somewhere else in your application, you could also add such type annotations to make sure that you, for example, only accept numbers, so-called integers, if you use the int value here. So that, for example, if you would pass some text here to this function, you would get an error because your function might not know what to do with text. It wants numbers, to add them as numbers, not to combine them as text. That's why this type feature exists. It's there to ensure that you as a developer can be clear about which kind of values you want to accept and which kind of values you don't want to accept. For example, the runApp function, which we're using in our code, wants a widget as its first and only argument. So a value of type widget. And it turns out that material app, which is in the end the value we are passing to runApp, is such a widget. And here for the text widget, we should of course go back to a real text. So that's the idea behind types. And in Dart, types are everywhere, not just in the parameter lists of functions. For example, this thing in front of main, this void thing, is also a type. It's the so-called return value type of the main function, but that is something we'll get back to later in the course once we actually have functions that do return something. Now, as mentioned, you can build your own types, and you also get many types by third-party packages, but Dart also ships with many built-in core types. Of course, you might not understand all of them just yet. You will see all of those and many more in action throughout this course, though. For the moment, the most important takeaway is that this types feature exists so that you can't work with the wrong types in the wrong places.